This presentation is it's about the process that we had to go through when we demolished part of Bradwell Power Station, and it's how the process had constraints over us initially, and then as time went on, and which is the bit that Andy picks up on, we then worked with collaboration with Magnox together and developed the process. Magnox is it's not a washing powder, it's a nuclear company. We own 10 nuclear power stations in the UK. Of those 10 power stations, only Wilfer, which is in North Wales, still generates electricity. The remaining 9 are in different stages of cease generation, different stages of decommissioning. So we've now got a program which is working its way through these power stations to carry work on. Bradwell Power Station itself was constructed in 1957. It started generating electricity in 1962, and we had 2 Magnox reactors which produced 240 megawatts of electricity. It ceased generation in 2002, sorry, and it goes into what we call final care and maintenance in 2015. Final care and maintenance is basically the whole of the buildings that aren't relating to the reactor are knocked down, and the reactor side itself is sort of bolted up, as it were. This is a photo just showing when the construction was commenced on site there. You can see it's quite a big area. It's on one of the estuaries around the Essex coast. And this is what it was like when it was actually generating. The area that we're talking about today is the Turbine Hall, which is that area around there. That's the area that the work was carried out in. So the overall strategy that we put together for demolishing this was we had to divert all the services to make sure that we could go into care and maintenance, island the buildings to make us cold and dark, and then hand over to the demolition contractor to deplant and demolish the Turbine Hall and carry all this work out safely. There was a hell of a lot of enabling work that had to be carried out before we actually got to the demolition phase. This is a list, and I won't go through it word for word, but there's a number of issues that we had to do. The electrical overlay system is what they do on our power stations. We basically take the electrically supply which went to the whole of the site and just put it into the nuclear island. So that's quite a big issue. So you can't really start any conventional demolition until such time as that is in place. So that was an issue. We had to relocate the workshops and the stores. We had to have new lay-down areas for waste. We had to characterise a lot of the material in there, which is to look at it and see if it's got any radiological contamination. Fortunately, in this case, it didn't. And then we had things to do like bat and bird surveys, because there was quite a lot of nesting birds when it was generating in the turbine hall. This shows you the turbine hall as it was. Again, we started over here. You've got this is the main turbine hall here. This is the auxiliary turbine hall, which had 3 turbines which were of smaller nature to the rest of it, and the idea was that we would take that out first and learn from that. So we had critical enabling activities which we had to isolate the services, and the way that Magnox do that is we cut cables and about a metre length like that, so that we ensure that everything is dead in there. Carry out an environmental clean. It had asbestos removed prior to the demolition commencing, but there was residual asbestos there because it was about 5 years before we started. So we had to do an environmental clean, and then there was a handover document which then gave us the site cold and dark, as it were, to carry out the works. This just shows you some of the cables that we had going through and into the power station, and this was the process that we adopted to isolate these. This is the site of Bradwell, which I've shown you some photos of, and our site boundary was, as we got there, we basically had an area around here which we put hoarding around there, and then it was a controlled access into that site from the power station. So, Magnox were the principal contractor under CDM. Well, CDM is what we use in the UK. I think the European directive for that is the Construction Sites Directive. So, but that's the CDM is what the UK use, or interpretation of that. Under this, you have the principal contractor. Well, with this particular project, Magnox initially decided that they would be the principal contractor. And so everything went through Magnox. So there were work control cards. So every activity you would carry out had to be carried out by Magnox to make sure the paperwork was in place to start the works. They controlled the access. Method statements had to go through Magnox, even though they didn't really have any knowledge of demolition. You would put a method statement into them, and then a committee of about 18 people would sit around a table and tell you that there wasn't an I dotted or a T crossed, and it was no knowledge of demolition, but they still maintained this control. All the waste was controlled by them as well, so they monitored everything going out. Again, there was this, we ended up with a staged handover because they couldn't totally give us everything. They gave us areas at a time where we would carry out the works. Then there was, as I say, the isolations. Supervision, they had almost man-for-man marking on us when we were carrying out the work. So it was very much them trying to control, really, something that they weren't having any expertise in. And before we could actually start work on the site, there was a readiness review. A readiness review, as far as Magnox is concerned, is you have to go through the whole of the paperwork. You have an army of guys that come around and look at it all. And then after that, they will walk around the site with you, and you have to tell them what you're going to do before they can actually carry the work, you can actually start work. So the early works were to take, as I said earlier, was to take out this area here and along that face there, which was the auxiliary turbine hall. This is the auxiliary turbine hall. There's 3 units in there. The auxiliary turbine hall served the actual power station when it was generating. They're only small units. I think they were something like 15 megawatts. So the idea was to deplant that. So we used that as a learning curve, shall I say, for carrying the works out. So we would use the overhead crane to take the items of plant out, and that would then put them onto the loading bay, and then we would have to get somebody from Magnox would characterise all the bits and pieces. So you've got these items here, all got numbers on them, so they would check that there was no radiological contamination on them. So that's the way that they would carry it out, but that was a very arduous process. Once we deplanted it, we actually put a ramp in and put a machine in there and managed to break out the concrete plinths and work our way through it. And then just conventionally we would take the overhead cranes down, taking the stops off either side and pulling it through. That on its own was really a momentous thing, because Magnox had not really seen any demolition of any degree until this happened, and they were all scared about what was going to happen, and we finally had to get across to them that it was standard practice. It's the way you do it, but they wouldn't have it, as it were. While the works was going on, we had a little incident where we had a fire. Now after that, we then sat down, reviewed everything, and modified all our process. So I'm now going to hand over to Andy, who will take you through the modified process from where we were.
Morning, ladies and gents. Thanks for that, Steve. So, moving forward, it was time to make up the hard yards and safely deliver this project. The modified approach was called for, as there was an event that Steve's described, and the project at Bradwell was becoming protracted with issues which were more common to an operational power station than that of a demolition project. Magnox still held the role of principal contractor, but both companies took a long, hard look at ways of streamlining the project, removing barriers, working together and achieving our common combined goals. Erith management and supervisory staff all received human performance training on error traps and operational behaviour, which helped further understand ways of working within a nuclear power station environment. A safety stand-down took place and all persons involved in the project reviewed their roles and ways of working. Following that process, which was quite long, a further readiness review took place, initially with asbestos removal, then mechanical demolition and deplant, and then finally hot working. This helped sort of remove the barriers that previously existed between the two teams and helped cultivate a way of working together as a team and not as an adversarial group. So, key areas that were jointly reviewed were the ways that we put people to work, hot works, team identification, document production, radiological waste monitoring, and weighing off demolished material. And the review headlines are basically shown here, so we went through that process for each of those headlines. Following on from that, a specific procedure or process was put in place and the works finally began to progress. Modified approach related to each of the headings that are shown here, and it was aimed at getting all people involved with the process of communicating in a better environment. Key to this was the need for pre- and post-job briefs. These were organised and were usually held in a designated meeting room with all persons involved in the day's work required to attend. The pre-job brief focused on the planned day's work, be it asbestos removal, deplant or demolition. The pre-job brief was normally delivered by a manager and helped to ensure that all parties involved in the work understood their role. Key elements: does everyone understand the scope of work? What are our expected results? And do you understand your role in this? Are there any parallel work activities or other work groups that could be affected by our planned day's works? What are the hazards? What are the controls? And what to do if things go wrong? Post-job brief, as the name suggests, was normally held at the end of the day's shift or the completion of the work task. We looked at, did it all go to plan? Can we do anything better? What did we learn? And Erith and Magnox found that post-job briefs encouraged shared learning and certainly cultivated a positive behavioural safety culture. As Steve alluded to, there were a great deal of Magnox people wandering around the site waiting to ambush us, so to help all parties involved with the demolition work understand who was who on site, bearing in mind, as I said, there could be up to 30 people involved with the demolition project, Erith implemented coloured hard hats on site to assist with recognition, and the slide here just shows the colours of hats. Managers wore black, supervisors blue, and so on. In addition to pre-job briefs and in reaction to the condenser incident that we had, Erith also held specific hot works briefs. So all persons involved with the day's hot works understood the agreed items of plant to be worked on, limitations of the permit, specific materials, parallel work, areas of concern, and of course the control measures. Hot works brief was always held at the work face with a Magnox SQEP in attendance at all times, and we just kept a written record, and then the necessary hot works permits were issued. To further supplement that, Erith carried out a full review within the Turbine Hall with our Magnox colleagues to help understand the component parts of each item of plant. This identified materials that could be hot cut and others that could not. Examples of these that Erith encountered could be former oil-filled systems that had residual contents, items of plant containing flammable metals, items of potential radiological concern, and items in sensitive or hazardous locations. We then went round the Turbine Hall, as this slide shows, and effectively colour-coded every single piece of plant and equipment in there, which was a long process. But we found this cut out the risk of human error and ensured that everyone involved in the demolition and deplant process understood precisely what could be worked upon with each demolition technique. However, prior to any real deplanting and demolition taking place, a lengthy phase of asbestos removal / environmental cleaning had to take place. So here this slide shows a large asbestos removal tent. The asbestos removal took around a year to complete with around 25 strippers and supporting supervisors, and as Steve mentioned, the asbestos was purportedly removed by 2 previous contracts, but Erith found there was a great deal of material still in place in a variety of applications, some hidden and hard to find, and others was just simply missed. With the previous strips, quill garnet proved to be a troublesome issue that Erith inherited from the previous strips and was a lengthy and labour-intensive product to remove. Erith made a major discovery under the decking of the stator units, which this slide shows here. It was a virtually inaccessible asbestos material and required the large horseshoe-shaped scaffold enclosure to be constructed, with further scaffolds also internally to access the material. Again, this was very labour intensive, and it was a discovery item, and it protracted our programme by around 12 weeks. So we soldiered on with the asbestos removal and environmental clean, and once we completed that, we could then start deplanting. Deplant work basically involves the systematic dismantling of various plant items to maximise recycling and enable radiological characterisation of hidden areas of plant. Erith employed a mixture of hot and cold cutting techniques, again based on our assessment of the plant items, their residual hazards, and our own tailored hot working procedure. Wherever possible, Erith always unbolted structures using hand and hydraulic tools, with hot works being used to supplement this when deplant wasn't practical with unbolt or mechanical. Deplant was very labour intensive, and Erith peaked with around 40 men on site deplanting the main turbine hall. And here this slide shows a low pressure steam cover being removed to reveal a magnesium rotor blade. Again, these blades, by virtue of their position in the turbine hall, hadn't been characterised, so basically we had to cut sections of that off and send it off to the USA for characterisation. This process could take up to 4 weeks to turn round, so again it did require meticulous planning to keep our programme ticking over, bearing in mind it was already considerably protracted. Erith always used machines to remove men from the workface when access permitted, particularly in the basement areas of the main hall and the Steam Annex once Steve had finally demolished the auxiliary turbine hall. Erith used two EX520s, PC600s and Dyson 300s to basically shear and rag items of plant into suitable sized sections for removal. And this slide shows a Dyson 300 with shear in action in the basement working around the condenser units. As Steve mentioned, use of the turbine hall cranes is essential for the deplant. This slide shows a 42-tonne rotor section that's been extracted from the stator units, being lifted out whole following a combination of manual deplant and hot works. Rotors were lifted out, transferred to the loading bay, landed onto a low loader and then simply removed off-site. The two overhead cranes within the turbine hall were essential, as I've mentioned, and we had one at 85-tonne capacity and one at 20-tonne. Both were re-energised and commissioned for the works, and we simply couldn't have done the job without the cranes. So following the deplant, we then moved on to demolition. Starting off, the auxiliary turbine hall had been our learning curve. We now moved on to the Steam Annex, which is a long linear structure, as shown here by the red hatch. The Steam Annex contained a great deal of steam pipework, vessels, motors, and associated plant for the production and management of steam. The structure itself was steel framed with a mez level internally constructive in situ concrete, and then at higher level you can see the Braithwaite water tanks. There was a robust steel beam arrangement supporting those. Each of those tanks went around 30 tonne when empty. The steam pipework that was contained inside the annex, with its inherent risk of stored energy, had a number of safety cuts carried out to de-risk the demolition once we got our plant and equipment in there. Erith used Hitachi 520 high reach with a rotating varactor to demolish the Steam Annex, and it's a fairly conventional demolition, as you can see. Working from the north, we simply remove the cladding, intermediate steels are removed, and finally the primary steel members removed. Water tanks are then simply grabbed, undercut, as you can see. We've removed the steel beams and undercut it here. And then we simply grab them and pull them over into a controlled drop zone. Hopefully this process will be shown now. I've got a little video clip for you to see of it going on. Fairly conventional demolition, but as Steve alluded to, trying to convince Magnox that this is the way that demolition operates was a very, very difficult process. It took around 6 weeks to convince Magnox that this was the norm. So as you can see, straightforward. Process was repeated throughout the entire length of the Steam Annex, through the 9 tanks, went successfully, safely carried out. Okay, So we've removed the tanks and we're working along the Steam Annex quite merrily. Turbine Hall demolition itself started then, again working from the north in a sequential bay-by-bay basis. Erith decladded the building, intermediate steel work was demolished, again with the use of high-reach excavators and guys working with hot works out of cherry pickers. The first two portal-based sections, as you can see here, have been removed, and the box beams have now been removed as well. Crane stop blocks are cut out, and then a PC600 with shear simply grabs the crane block on the ropes and drives backwards. Again, straightforward conventional demolition which took weeks to convince Magnox. So attendant excavators then downsized that and we shipped it out. That's the 85-ton crane gone. Demolition of the main hall structure itself was a process which was simply repeated throughout the length of the portal bay structure. Again, hot working operatives accessing at high level via mupes were used to sit cut the beams, as you can see here. These are all prepared. This one's gone, the excavator's in position. We've obviously carried out some hot works here on the columns just above crane rails. Basically the excavator's in position, ready to pressure the final tags that we've left on for a controlled collapse. And here you can see the process is now starting with the safety tags failing and the bay collapsing nicely into a designated drop zone. Attendant excavators then downsized the bay and the material was cut up for removal. The remaining crane rails and column sections that were then cut out and demolished again with a 600 or 450, and that process was repeated throughout the whole length of the turbine hall structure. So here you can see the superstructure itself has now been fully demolished. This shot is one I took from the top of the reactors, and now you can see the final elements of the mechanical deplant with the blue stators here, 130 tonne each, and below them the 70-tonne condensers. Finish lines now well and truly in the site. Final elements of mechanical deplant took place with condenser units as shown in this slide being sheared with a 600, and again construction materials being segregated and off-sited. Once the condensers had been demolished, the stator units were simply pushed off the top of their plimps mechanically and then cut up, using a combination of hot works and mechanical shear. Both the inner and outer cores of the stator units were crane lifted onto low loaders and then sent off-site whole for further processing and recycling. Next up were the turbine blimps. These were large concrete structures and proved to be very, very robust and tested every item of plant that Erith employed. Erith used a PC600, Dyson 480 and two PC450s for this part of the works. Krupp and Rammer hammers were used for the work, and again it took around 6 weeks to complete, and we completed it around 3 weeks ahead of our programme. All the concrete arisings for the entire project were crushed by two Terex mobile track crushers, and again this work took around 4 weeks to complete and was completed ahead of schedule. The crushed material was simply spread out over the turbine hall void itself, infilling ducts and voids. We also formed a ramp that you can see at the far northwest corner of the site. And here the project's essentially complete. We've put a fence around the site and all materials removed. Site's handed back to Magnox. So, programme performance, a quick summary here for you. As you can see, we completed the project 2 months ahead of our baseline programme. We resourced a major asbestos discovery item. However, main success as far as Erith and Magnox are concerned is 125,000 man-hours worked without an LTA. Just to give you a little flavour of the number of shipments of material you're likely to send off-site if you do ever demolish a turbine hall. You can see here the peak of the material being removed off-site is July and August when we demolished the Steam Annex and main turbine hall. Materials basically removed off-site by either low loaders or articulated bulkers. And again, we feel this is another success story of the project, bearing in mind every shipment of material off-site needs scanning for radiological clearance and then a quality plan, again for each bin, requiring 7 signatures from Magnox to approve. All in all, it's quite a lot of legwork just to get material off-site. Waste management and performance there, figures really do speak for themselves. 91% of the arising material was scrap material, which was basically sent out into the UK construction marketplace, and the remaining 9% mixture of asbestos and soft strip. So to surmise, as you can see, 125,000 hours, project completed 2 months, ahead of our baseline. We made a large saving back to our client Magnox, 2.3 million. 12,900 tonnes of material back out into the UK construction marketplace for recycling. And overall, the project was a collaborative success between Magnox and Erith in the end. Both companies achieved our goals, and we cultivated a working future on other Magnox sites. The future did become clearer for Erith and Magnox when Erith successfully tendered to be a framework contractor with Magnox over 10 years. Erith qualified for 2 packages of work, namely deplant and demolition outside the RCA, and asbestos removal inside and outside the RCA. Okay, that's it for me, so I'll hand back over to Steve for a look at the future at Bradwell and other Magnox sites.
Just to give you a little bit of a view of what happens on the reactor side of things once you've got rid of the conventional work. This is a cutout of the reactors at Bradwell. What we would be looking to do, and in fact we've got work going on now, is to take these boilers which you've got on either end of the reactor. We take the main elements of pipework away from those. There's headers in there. They all come away, and when we leave that basically just standing on its own when it goes into care and maintenance. You've got the pole cap in here, and you take off all of these elements of plant in here, and again leave that in with basically just nothing in there at all which would cause any problems. This is just a view looking up inside one of the boilers. You can see all these You can see all the pipework in here. Basically, once you've taken it out, you then have these little stubs left on the main boilers themselves, and then that will stand. There'll be a little bit of structural support to the boiler, but other than that, there's no further work with that. So this is where it is basically, or will be, shall I say, midway through the decommissioning. You've got the reactors here, which have still got to be deplanted there, etc. And then finally you end up with this, which is what we call it going into care and maintenance. So you've got all of the outside buildings gone. The 2 reactor buildings here are just, they're actually going to be reclad and then just left like that. And then it remains like that for about 80 years until the radiological contamination dissipates. And that's the way we end it. So that's it. Thanks very much.